Hey, so those of you who follow me on Instagram have probably got a vague sense that I've been working on something electronics and video related. I'm not ready to do a full video right now, but I've been working on sort of a hybrid digital analog video synth. This is a thing I used to do a lot of like 20 years ago now, but technology has come a long way. So those of you who've been sick of looking at this image on my Instagram and various variants of it, I'll do a quick explanation of what I've been up to. And I got a comment on the video synthesis subreddit wanting a quick explanation of how one of these bits of the circuit works. So I'm going to come in and show you that. So what I've been doing is piping out HD 1080p 24 video from my computer over there and sending it out over component. Component is a 3-channel signal. There's a composite, a combined luminance and sync channel that runs over the green wire. Then over the red and the blue, you have the red information minus luminance and blue information minus luminance. And unlike composite video, which just runs over a single wire, which basically goes up to NTSC or PAL resolutions, component video can do 1080p, which is pretty awesome. So I've been building some circuitry to separate out the luminance and the sync, which you need to do to be able to work on the luminance separately. So I've got some circuitry that does that. I've got some amplifiers, some impedance matching, and now I'm starting to sort of mix in audio and sort of procedural code to process the image. So I'll start off with a quick tour of the circuit. Quick overview, I like to prototype on breadboards and move things as they're done or finalized over to little PCB boards and then sort of glue those guys together. So it's messy right now, but I'm going to clean it all up as I go. Over here we have a power supply providing plus or minus 5 volts and ground. Over here we have a board that's really focused on removing or separating out the luminance and the sync signal from that green wire which comes in over the component cable. To do that, I have a pick chip which I programmed to identify the 2 different parts of the signal and generate a few different clocks related to the timing of the frame rate and the line rate and things like that. Then we have 3 op amps here, LM7171s, which are high speed, high bandwidth op amps that allow me to process HD video and sort of impedance match and give me a clean buffered signal that I can work with later on. Then down here we have some glue logic, some AND gates and OR gates and stuff that allows me to generate some more signals from the clock here, allowing me to combine and recombine the luminance and the sync. And this board over here, there's another pick chip back here that's sort of serving double duty. It's an 8-pin chip, but I've got it set up to take in 8 analog inputs, which come in from audio inputs and knobs that I'll have on the front panel. And it generates sort of a pixel clock using timing signal coming out of this pick chip. Back here we have a free running voltage controlled oscillator, which sort of gets phase locked to the pixel clock using this chip here. That's a very quick overview of what's going on up here. What's really of interest is where everything sort of comes together, and this is the final board, the final boss, if you will, which takes in all the stuff coming out of here and recombines it to make interesting outputs. And I want to zoom in on this single transistor here. So this little NPN transistor is taking an audio signal in and using it to turn on and off and sweep on and off the luminance signal. I have 2 potentiometers connected to it. One allows me to bias the NPN transistor, so I can set how much of this audio signal is in the sweet spot for turning the transistor on and off. Then I have another potentiometer which allows me to choose, is the output seeing sort of the collector side or the emitter side of the transistor, which is like, is it seeing the pre-processed or the post-processed part of the signal? And it comes up with a really cool effect. So I'll show you that on the screen and then we'll draw out this circuit diagram for you. Let me preface this by saying I am by no means an analog expert. I discovered, however, a long time ago, it's really hard to blow up external equipment, so it's okay to play, but you know, take this with a grain of salt. So this is all based around a single NPN transistor. We have our base, collector, and emitter. If you're not familiar with transistors, they're sort of switches or amplifiers. I'm going to label these collector, base, collector, emitter. If you look at the current flowing through the base and the emitter, and you put it on this axis, you'll get a resulting amount of current that can flow through here. And you sort of get a curve that looks like this. So if this current going through here is really low, this is basically off. If it's really high, it's basically on. And has this nice sort of sweet spot in the middle, which sort of can act as an amplifier, where a very small change in this current can lead to a large change in the collector emitter current. I don't think using a fat Sharpie was the best idea. So what we have is we have an audio signal which switches on and off this transistor. I'm going to stick it up here for a moment. See if I can use the less sharp end. Audio in. All right. Now, as I said, there's this sweet spot region in here where the transistor is acting like an amplifier. To get to that region, you need to bias the transistor, which means sort of give it like this voltage divider here, which has ground on one end and has plus 5 volts here. And that's a potentiometer. So you can sweep it up and forth. When it's up the top, you're going to be at 5 volts. When it's at the bottom, you're at 0 volts. And if it's a linear taper potentiometer, you'll move linearly between those two. And that will then get summed with the audio coming in, which is a voltage that goes plus or minus 1.5 volts peak to peak, I think, at line level. And that will allow you to sort of get yourself into this region here. And then what we have is we have the luminance of the component video signal coming in here. So luma in. Sorry, this is very messy and I'm hard to write with the camera in the way. And rather than going straight to the emitter being luma out, we're putting another voltage divider in here. And luma out is coming out here. And this basically, when this potentiometer is all the way at the bottom, what's going to happen is when the transistor is on, the luminance signal is going to flow through the transistor and come to luma out. When the transistor is off, you'll get no luminance, so this image will be dark. When this potentiometer is all the way up here, it doesn't really matter so much what the transistor is doing. You just get the in signal coming to the out signal. Now there's a lot of caveats here because current does flow through a transistor. Just by way of whatever, I'm using a BC548 NPN. There's an entire art and science to choosing transistors. Basically, I have buckets of NPNs and PNPs, and I just play and find the ones that I think work well for whatever I'm trying to do, usually aesthetically or sonically or visually or whatever. So yeah, that's basically it. There's a lot of reasons why this is a bad circuit, but it works and it doesn't blow anything up and it's fun to play with, and hope this gets you started on just playing with cool stuff. The other thing I think I was doing on that Reddit post is I was using low pass filters, which is a resistor and a capacitor going to ground, and the signal goes out this way. This allows you to get smearing of the image, particularly bright borders get smeared across. Yeah, two little very simple circuits that might seem daunting if you're just staring at it for the first time, but hopefully breaking it down, it's not as daunting. All right, have fun out there. See ya. Bye.